Welcome to Sasit Teaching. This is your first grade 9 mathematics lesson of term 1. Today we will be focusing on the number system. Let's go! Unit 1. The number system. Do you know the number system? Let's have a look at real numbers. Real numbers consist out of rational numbers and irrational number. And if we want to define rational numbers, we can say it's a number that has to be written in the format of A over B, where B is not allowed to be equal to 0. Unit outcomes. After completing this unit, you should be able to 1. Know basic concepts and important facts about real numbers. 2. Justify methods and procedures in computation with real numbers. And 3. Solve mathematical problems involving real numbers. Introduction. In our grade, you have learned about rational numbers, their property, and basic mathematical operation you use them. After a review of your knowledge about rational numbers, you will continue studying the number system in the present unit. Here, you will learn about irrational numbers and real numbers, their property, and basic operation you use them. Also, you will discuss some related concepts, such as approximation, accuracy, and scientific notation. 1.1 Revision on sets of rational numbers. 1.1.1 Natural numbers, integer, prime numbers, and composite numbers. In this subsection, you will revise important facts about the sets of natural numbers, prime numbers, composite numbers, and integers. You have learned several facts about these sets in previous grade, in grade 7 in particular. Definition 1.1 Prime number and composite numbers. 1. A natural number that has actually two distinct factors, namely 1 and itself, is called a prime number. 2. A natural number that has more than two factors is called a composite number. Note: 1 is natural prime non-composite. Example 1. Use the divisibility test to determine whether 2416 is divisible by 2, 3, 4, 5, 6, 8, 9, and 10. Solution 1. 2416 is divisible by 2 because the unit digit 6 is divisible by 2. Next, 2416 is divisible by 4 because 16, the number formed by the last two digits, is divisible by 4. Next, 2416 is divisible by 8 because the number formed by the last three digits, 416, is divisible by 8. And 2416 is not divisible by 5 because the unit digit is not 0 or 5. Similarly, you can check that 2416 is not divisible by 3, 6, 9, and 10. Therefore, 2416 is divisible by 2, 4, and 8, but not by 3, 5, 6, 9, and 10. A factor of a composite number is called a prime factor if it is a prime number. For instance, 2 and 5 are both prime factors of 20. Every composite number can be written as a product of prime numbers. To find the prime factors of any composite number, begin by expressing the number as a product of two factors, where at least one of the factors is prime. Then continue to factorize each resulting composite factor until all the factors are prime numbers. For example, the prime factorization of 60 is 2 times 2 times 3 times 5 is 2 power 2 times 3 times 5. The prime factorization of 60 is also found by using a factoring T. Note that the set 2, 3, 5 is a set of prime factors of 60. Is this set unique? This probability leads us to state the fundamental theorem of arithmetic. Theorem 1.1 Fundamental theorem of arithmetic. Every composite number can be expressed factorized as a product of prime. This factorization is unique apart from the order in which the prime factor occurs. Example 2. Find the prime factorization of 1530. Solution: start dividing 1530 by its smallest prime factor. If the question is a composite number, find a prime factor of the question in the same way. 1530 divided 2 is 765, and 765 divided 3 is 255, and 255 divided 3 is 85, and 85 divided 5 is 17. Therefore, 1530 is 2 times 3 power 2 times 5 and times 17. 1.1.2 Common factors and common multiples. In this subsection, you will revise the concept of common factors and common multiples of two or more natural numbers. Related to this, you will also revise the greatest common factor and the least common multiple of two or more natural numbers. Given two or more natural numbers, a number which is a factor of all of them is called a common factor. Numbers may have more than one common factor. The greatest of the common factors is called the greatest common factor, GCF, or the highest common factor, HCF, of the numbers. Note: the greatest common factor of two numbers A and B is denoted by GCF AB. Example 1. Find the greatest common factor of A 36 and 60, B 32 and 27. Solution: A. First, make list of the factors of 36 and 60. Using set, let F36 and F60 be the set of factors of 36 and 60 respectively. Then F36 is 1, 2, 3, 4, 6, 9, 12, 18, and 36. And F60 is 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. You can use the diagram to summarize the information. Notice that the common factors are shaded in green. They are 1, 2, 3, 4, 6, and 12, and the greatest is 12. And F36 intersection F60 is 1, 2, 3, 4, 6, 12. Therefore, GCF 36, 60 is 12. Solution: B. Similarly, F32 is 1, 2, 4, 8, 19, and 32. And F27 is 1, 3, 9, and 27. Therefore, F32 intersection F27 is 1. So, GCF 32, 27 is 1. Note: two or more natural numbers that have a GCF of 1 are called relatively prime. Definition 1.2. The greatest common factor, GCF, of two or more natural numbers is the greatest natural number that is a factor of all of the given numbers. Example 2. Use the prime factorization method to find GCF 180, 216, and 540. Solution: Step 1. Express the numbers 180, 216, and 540. In their prime factorization, 180 is 2 power 2 times 3 power 2 times 5, and 216 is 2 power 3 times 3 power 3, and 540 is 2 power 2 times 3 power 3 times 5. Step 2. As you see from the prime factorization of 180, 216, and 540, the numbers 2 and 3 are common prime factors. So, GCF 118, 216, and 540 is the product of these common prime factors with the smallest respective exponent in any of the numbers. Therefore, GCF 180, 216, and 540 is 2 power 2 times 3 power 2 is 36. Definition 1.3. For any two natural numbers a and b, the least common multiple of a and b, denoted by LCM AB, is the smallest multiple of both a and b. Example 3. Find LCM 8, 9. Solution. Let M8 and M9 be the set of multiple of 8 and 9 respectively. M8 is 8, 16, 74, 32, 40, 48, 56, 64, 72, 80, and 88. Next, M9 is 9, 18, 27, 36, 45, 54, 63, 72, 81, and 90. Therefore, LCM 8, 9 is 72. Prime factorization can also be used to find the LCM of a set of two or more than two numbers. A common multiple contains all prime factors of each number in the set. The LCM is the product of each of these prime factors to the greatest number of times it appears in the prime factorization of the numbers. Example 4. Use the prime factorization method to find LCM 9, 21, and 24. Solution. 9 is 3 times 3 is 10 power 2. Next, 21 is 3 times 7. And 24 is 2 times 2 times 2 times 3 is 2 power 3 times 3. The prime factors that appear in these factorizations are 2, 3, and 7. Considering the greatest number of times each prime factor appears, we can get 2 power 3, 3 power 2, and 7 respectively. Therefore, LCM 9, 21, and 24 is 2 power 3 times 3 power 2 times 7 is 504. Note: for any natural numbers a and b, GCF every time LCM every is a times b. 1.1.3 Rational numbers. Historical note: about 5,000 years ago, Egyptians used hieroglyphics to represent numbers. The Egyptian concept of fractions was mostly limited to fractions with numerator. 1. The hieroglyphic was placed under the symbol to indicate the number as a denominator. Study the examples of Egyptian fractions. Recall that the set of integers is given by that is -3, -2, -1, 0, 1, 2, 3. Using the set of integers, we define the set of rational numbers as follows. Definition 1.4. 4. Rational number. Any number that can be expressed in the form a over b, where a and b was integer and b not equal 0, is called a rational number. And the set of rational numbers denoted by Q is the set described by Q is a over b, so a and b are integers and b not equal 0. Through the following diagram, you can show how sets with rational numbers are related to each other. Note that natural numbers, whole numbers, and integers are included in the set of rational numbers. This is because integers such as 4 and -7 can be written as 4 over 1 and -7 over 1. The set of rational numbers also includes terminating and repeating decimal numbers because terminating and repeating decimals can be written as fractions. Next, example 1. Write 30 over 45 in simple form. Solution: 30 over 45 is 2 times 3 times 5 over 3 times 3 times 5 is 2 over 3 by factorization and cancellation. Hence, 30 over 45 when expressed in lowest term, simplest form is 2 over 3. Rational numbers are numbers that consist out of natural numbers, whole numbers, integers, and fractions. So if we have a closer look at natural number, it starts from the word 1, 2, 3, 4, 5, 6 till infinity. When we look at whole numbers start from 0, 1, 2, 3, 4, 5 till infinity. Integer is all the numbers that is greater than 0 for instance 1, 2, 3, 4, 5 till infinity. And also if we look at word that is smaller than 0 like -1, -2, -3, that is also part of the integer number system. And fractions are also part of rational numbers, and remember we rewrote all our whole numbers, all natural numbers, all integer as fraction to indicate that it's a natural numbers. Practical example of a fraction would be a half, 4 over 3, 5 over 11, and 2, 1 over 4. And the last, are natural numbers, a number that cannot be written in the form a over b. It is a non-repeating and never-ending decimal. So, example 0.12571350009 till infinity. Yeah, after watching, how was it? I hope you enjoyed and learned about the number system. And see you again. Bye.